Alright folks, welcome to the probability and stats section. If you haven't watched any videos yet, that likely means that this is the route that you decided to take. You're going to take maybe AP Stats next year. You might decide that you like the real world application more than you like the compute and figure out kind of applications. That's really what this is. This section is called sample spaces and probability. And really, this is going to take a lot of common sense and just thinking through a problem logistically. You have to think through a problem, be able to see something, and then picture it in your head, and then be able to go through that process. Okay? So the first part is going to be all about definitions. So a probability experiment, you know what an experiment is. So an experiment, my handwriting on this is just as bad as it ever has been. An experiment is an action, a trial, an observation, something that you can do that yields results, right? I mean, you all know what that is from chemistry, so it's something that happens, or something that you do that has a result. It's something that you're trying to see, okay? There are things called outcomes. You know what an outcome is, right? An outcome is, like, for instance, I roll a die, and when I roll that die, the options could be that I have a 1 through 6. I have a 1, 2, 3, 4, 5, or 6. That's the outcome, right? When I roll a die, that's the thing that's going to happen. We have events. An event is something happening, like something. It's something in general, right? Like you flip a coin and something happens. Or you roll a die and something happens. So something like maybe a roll is odd. So that could be one of your outcomes. A roll is odd, okay, or one of your events. And then finally, the sample space. Oops, I'm going to rewrite that. The sample space is the set of every possible thing that could happen. So the sample space is all possible outcomes. So that's like me saying if we flip a coin, there's the sample space is 2 because it's either going to be heads or tails, right? Now, something that's going to have to happen, you're going to have to think about this without putting on that super constructive criticist hat that you have all the time, where it's like, what happens if I flip a coin and it lands on its side? That's not going to happen, okay? We're thinking of things legitimately, like if I flip a coin, it's either going to be heads or tails. It's not going to land on its side. It's not going to fall down the sidewalk crack, and then I'm never going to be able to find it and not know what it came up with. You have to think of it legitimately, okay? So here's a way that we figure out outcomes, right? So let's say that we want to flip a coin, then roll a die. First thing that I'm going to do, my first event is flipping a coin, right? That means there's two options. It can be heads or it can be tails, right? So there's two outcomes for flipping a coin. So I'm going to flip my coin, and then I'm going to see that it's heads. I'm going to put the coin down, and then I'm going to do something else, and what I'm going to do is now roll a die, and there's really 6 possible outcomes for rolling a die, right? I could be 1, 2, 3, 4, 5, or 6. And I could do the same thing with tails. So it's going to be 1, 2, 3, 4, 5, or 6. So there's 12 possible things that could really happen here. There's 12 outcomes, right? I could do heads and then roll a 2. I could do tails and then roll a 4. There's 12 possible outcomes that I could probably have. All right? So now the next thing that we have to kind of talk about is what probability really is. And I'm sure most of you already know this, but probability is how likely an event is to happen. So it's on a scale from 0% all the way to 100%, right? And if you look at the weather is all about probability. If there's a 0% chance of rain, you know that it's not going to happen, right? If it's a 0% chance of rain, it's not going to happen. If it's 100%, I should put not happening. If it's 100%, then it's certain. Anything in the middle is either, likely to happen, not likely to happen. If you think of Frankie Moo's snow day calculator, the one that used to be run, whatever, by you guys, they were pretty good, 0% or 100%. It either is or is not going to happen. If you think of Mr. Kroger's snow day possibilities, those are kind of like, 80% means that it could happen, it might not still, but it's more likely to happen than not, right? So that's what probability really is talking about, okay? So now we're going to get into a couple of different types of probability. The first one is called theoretical. I'm trying to write with a stylus on this thing, and I apparently don't pick it up high enough, so my handwriting is going to be really bad. If you have questions, make sure you ask. Theoretical probability is what you want to happen over the total possibilities, or the total outcomes. So, like if I want to roll a 5, there's only one way to roll a 5 on a dice, right? That's like when you roll, and it comes up 5. So the probability of rolling a 5 on a die is 1 out of 6, because there's 6 total things that could happen, and there is one thing that you want to have happen, and that is that it's a 5. Okay? So now, a next thing that we're really thinking here, and I'm just going to read this, so you might have to stop and like rewind it, because it's a lot to write down. But a student flips a coin 4 times. What's the probability of getting exactly 3 heads? So we want to know what the probability is that this student flips a coin and it comes up heads 3 times. There's really a whole bunch of different things that could happen, right? We could get 0 heads, we could get 1, we could get 2, we could get 3, or there could be all 4. But now what we have to do is we actually have to go through and figure out exactly what all the outcomes look like. If it's 0 heads, that means that it's all tails, right? If it's 1 head, then that means it's going to look like this. Now when you look at this, notice that really it's just saying that we got heads at different times. So I flipped 3 tails, then my last coin was heads. Flipped 2 tails, then the next coin was a heads, then tails. Tails, heads, tails, tails, heads, tails, tails, tails. Right? So that's what you have to think about when you go through this. Okay? So now if we go through and we get exactly 3 heads. Or I'm sorry, 2 heads. So if it goes tails, tails, heads, heads. So now this is where we have to really start paying attention to making sure that we get every possible outcome. Hopefully I have enough space to fit this. I think I'm missing one. That one. Missing heads, tails, heads, tails. This is where it's really beneficial to have you guys in here with me, because you guys can tell me whether I'm right or whether I'm wrong. Now when we go through 3 heads, oops, that's the same one. Alright, so we have those 4, and then finally when we have all 4 heads, it looks like this. Now, I'm not going to ask you to do this a million times to come up with every single possibility, because it's really easy to forget them. This is really easy for me because I have them sitting right next to me, and I can look down and make sure that I see it, and I also knew that I had it. But when I look at this, how many ways are there to roll 3, or to flip exactly 3 heads? There's 4, right? So there's exactly 4 ways for that to happen. How many total outcomes? There's 1, there's 4, 6, 4, and 1. So that 1 plus 4 plus 6 plus 4 plus 1 is 16. And 4 over 16 simplifies down to 0.25, and 0.25 is the same thing as 25%. So the probability of rolling exactly 3 heads is 25%. Okay? The next thing, so the way that's actually written looks like this. Probability of 3 heads equals 25%. So if you're interested in what that looks like, you could also say 0.25 because it means the exact same thing. That's just on a scale of 0 to 1 instead of 0 to 100. Okay? Now the next thing is the complement of something. So like complement of anything. And what this really means is, what is the probability that something won't happen? So this is the probability that something won't happen. Like, for instance, I could say, what's the probability that and the way that this is, oh geez, my children are playing right now. So this is the probability that I don't. That's the way that it's written. So it's probability of A. What's the probability that I don't roll two heads? Or don't flip two heads? So the way that you say this, or the way that you do this, is you'll just say, well, everything together makes up 100%, right? And 100% is the same thing as 1. And if I take away all the times that two heads comes up, that leaves me with everything else, right? Like if I take my entire set, and I take away, if I look at this list, if I take away this entire list right here, then what that really means is that list now doesn't exist. Everything else is what's left. That's how we find a complement. So if I want to find this, I would just take 1 minus the probability that two heads comes up, and that's going to leave me with everything else. That guarantees me that two heads doesn't happen. And I know that there were 6 ways to roll two heads, so it's going to be 1 minus 6 over the 16. And then that's 16 16 minus 6 16, so it's going to be 10 over 16. And 10 over 16 is the same exact thing as, what? Oh geez, now I have to do mental math. 5 over 8. Okay? So 6 over 16 is the same thing as 5 over 8, which computes down to, oops, hang on, probably so, about 63%. So this computes down to about 63%, 62.5% if you're being exact. Alright? So that's what a probability looks like. Now the next part, this one's kind of an easier part too. This is just geometric, and this one I'm not going to go through too many examples of because you already know how to do this. I am going to upload my notes, which have an example worked out, but for time's sake, I'm just going to go through the generic part of this thing because you've already done this in geometry last year. This is geometric, and basically what we're looking at here is we're saying, like if I have a shape like this, and I put this thing in here, it's going to ask me something along the lines of, if a randomly chosen point is put on this piece of paper, or on that picture, what's the probability that it will land in the circle? So the way that you're going to want to do that is you're going to want to say the area of the circle over the area of the total. So I'm just going to calculate the area of the circle, and then write down whatever that is here, and then I'm going to calculate the area of the entire square and put that there, and that's going to give me my geometric probability. So you're just finding the area of the circle over the area of the total, and then hitting the enter button on your calculator. It's just area calculations. If you need to find area stuff, Google how to find area of a circle, and it'll show it to you. Okay? And then the very last thing that we have to deal with is experimental, and this one is by far the easiest. So what you're looking at, I used an example out of your book in section 10.1, and so what this actually is saying that somebody went through and did an experiment already. So for instance, they spun a spinner 20 times. So they spun that spinner 20 times, and the spinner has 4 different options. It's got blue, it's got green, it's got red, and it's got yellow. They actually did this, and they're saying that the number of times it came up blue was 9, the number of times it came up green was 5, the number of times it came up yellow was 3, and the number of times it came up red was 3, and the number of times it came up yellow is 3. If you add all those together, it gives me 20 times. Now, if they ask you something like, what's the probability that it was red? You literally take what they gave you, this, so 3 over the number of times you spun something, which is 20. So this is literally just a look at the number and put it over top of whatever the other number is. So probability of red was 3 over 20. You can calculate that to a percent if you want to. You don't have to. We could say, what's the probability that it's not blue? Probability that it's not blue is just 1 minus the probability that it was blue. And I can tell that the probability that it was blue was 9 over 20. So that's going to be 20 over 20 minus 9 over 20, which is 11 over 20. So that basically means there were 11 rolls that were not blue, or 11 spins that were not blue. That's what we're dealing with here. Okay, I'm trying to keep all these videos to about 15 minutes, so if I were you, what I would do is I would, watch the video, take notes on it, which means you're going to have to pause it and stuff, and then I would call that good for the day. And then the next day I would come back, I would look at some of your questions and some of the suggested problems on the worksheet, spend 20 or 30 minutes on those, send questions my way. Okay, I'm not trying to beat you to death with these things. I'm trying to shorten them down quite a bit. So if you have any questions, make sure that you ask. I'm giving you the really cut and dry thing of this. Okay, so if you have any questions, make sure that you let me know. Otherwise, I'll see you next time.